So today, yesterday, last class, we were discussing about the various types of what? The various types of advanced measuring instruments. I hope so you remember. Can anyone of you tell me what are the basic types of advanced energy instruments which you have described here? Can anyone of you tell me? Rahul, can you just name them? That's enough. Could you just name them?
Yes, sir.
And after that, we have taken the various types, you remember, of laser interferometers. In that laser interferometers also, we have different types of everything. What are the components, everything? Or can you tell me that? What are the components of the laser interferometer?
Sir,
Ah.
beam splitter,
Yeah, beam splitter, correct. Beam splitter, then
beam bender,
beam bender, okay, then
retro reflector.
retro reflector, okay. So these are the components, okay. So it also has got a two frequency laser system, optical systems, laser head measurements, measurement display, everything. So I hope so you remember. So now we are going to start about today. We are going to start upon another. All this comes under where? All this instrument measurement type of instruments comes where? Comes under which category? Can anyone of you tell me? Comes under which category all this comes? Not Rahul. Someone else can say. Okay. Comes under which category? Karthik, could you just tell me all these types of studies laser interferometer? Today we are going to study CMM. Okay, that is the name as coordinate measuring machine. So all this comes under which category? Can anyone of you tell me? Karthik.
Interferometer.
Yeah, okay. Interferometer, everything comes under which category? Under which category it comes? That's not my question. This all comes under which category? Hmm? This all comes under which category? Can anyone tell me? Not anyone? Karthik. It all comes under advanced measuring instruments. That's what the topic which is studied. Okay. It all comes under the advanced measuring instruments. That's what we say. Okay. Got it, Karthik? So, okay. So, today we will be starting with advanced measuring instruments where we will be starting with CMM. The full form is coordinate measuring technique. Okay. The coordinate measuring technique. That's we name it as CMM, or we can say coordinate measuring machine also. Okay. Technique or machine. Both are same. Okay. CMM we say. Coordinate measuring machine. Just note it down the name. Coordinate measuring machine. So a simple flowchart is being defined over here to understand the basic working, okay, of CMM, to understand the basic working of CMM. That's what we say. Okay, so it is mainly named as coordinate measuring machines. Okay, so the term itself, okay, the term machine generally refers to a single axis measuring instrument. Okay, so mainly the term CMM, it mainly refers to a single axis. Okay, so the term CMM mainly refers to a single axis measuring instrument. That's what happens in the case of coordinate measuring machine. So what happens over here is the term measuring machine generally refers to a single axis measurement. The term machine generally refers to a single axis measuring instrument. Such an instrument is capable of measuring one linear dimension at a time. It is mainly used for capable of measuring one linear dimension at a time. That's what happens in the case of a coordinate measuring instrument. In the case of a coordinate measuring instrument, the term measuring machine generally refers to a single axis, okay, generally refers to a single axis measuring instrument. It mainly refers to a single axis measuring instrument. So what happens here is in the case of coordinate measuring instruments, the term measuring machine, okay, the term measuring machine generally refers to a single axis measuring instrument. Such an instrument is capable of measuring one linear dimensions in a time. Such an instrument is capable of measuring one linear dimensions at a time. So the term coordinate measuring machine, okay, the term coordinate measuring machine refers to the instrument machine. Okay, the term coordinate measuring machine. The term coordinate measuring machine refers to the instrument machine that is capable of measuring in all the orthogonal axes. That is capable of measuring in all the orthogonal axes. So such a machine, okay, such a machine is mainly used. So in the case of a coordinate measuring machine, A coordinate measuring machine is a sophisticated measuring device. It is always a sophisticated measuring device used to determine the geometrical characteristics of an object operating in a three-dimensional space. Here we can see a cube which is already substituted. So what happens is we have a coordinate measuring machine. It is a sophisticated measuring device. It is always a sophisticated measuring device used to determine. Okay, it is mainly a coordinate measuring machine. It is a sophisticated measuring device. It is a sophisticated measuring device used to determine the geometrical characteristics. Used to determine geometrical characteristics of an object operating in three-dimensional space. Operating in three-dimensional space. That's what happens in the case of a coordinate measuring machine. In the case of coordinate measuring machine, okay, it is a sophisticated measuring device. Okay, it is a sophisticated measuring device. Okay, it is a sophisticated measuring device used to determine the geometrical characteristics of an object. Used to determine the geometrical characteristics of an object. Okay, so in the case of a coordinate measuring machine, CMM. Okay, so a coordinate measuring machine is a sophisticated measuring device used to determine the geometrical characteristics of an object operating in three-dimensional space. It is mainly operating in three-dimensional space. Then CMMs are mechanical systems designed to move a measuring probe to determine the coordinates of points on an object's surface. So these machines can do 100% dimensional assessment and are versatile in their capability to record measurement of complex profiles with high sensitivity and speed. So what happens is here we have an coordinate measuring machine. Okay, here we have a coordinate here we have a coordinate measuring machine. Okay, so a coordinate measuring machine is a sophisticated measuring device. A coordinate measuring machine is a sophisticated measuring device which is used to mainly to determine the which is mainly used to determine the geometrical, okay, mainly used to determine the geometrical characteristics of an object operating in a three-dimensional space. It is always in a three-dimensional space. And CMMs are mechanical system designed to move a measuring probe. A measuring probe is designed to move, okay, to determine the coordinates of points of an object surface. These machines can do 100% dimensional assessment. These machines can do 100% dimensional assessment and are versatile in their capability to record measurement of complex profiles with high sensitivity and speed. So these machines can do 100% dimensional assessment. Okay. So these machines can do 100% dimensional assessment and are versatile in their capability and are versatile in their capability to record measurement of complex profiles with high sensitivity and speed. With high sensitivity and speed. Then need for CMMs. What happened? Need for CMM. What is the main need for CMM? That's what we are going to say. So here what happens is the automation of a machine. So here what happens is first of all that we can say, see, small words, in simple words, using a probe, coordinate points of the object is registered. Then based on the coordinate points, a model is generated in the computer. This model is evaluated and compared with the design conditions of the object. So what here we have an object, a cube to be tested. The cube which has coordinate points, and then it is substituted the shape formed by the CMM machine. Then final report is being made after checking the product. So this is the workpiece, which is can be named as XYZ. Okay. So probe is made to touch various points of the object. Mainly we have a probe which is made to touch the various points of the object, and probe with the help of transducer sends the coordinate position data of each point to the computer. So what happens is here what happens is we have a probe. The probe is made to touch various points of all of the object. Okay, probe is made to touch the various points of the object. Then probe with the help of transducer sends the coordinate position data of each point to the computer. Okay, so what happens is here what we have is a probe is made to touch the various points of the object, and probe with the help of a transducer sends the coordinate position data of each point to the computer. Okay, of each point to the computer. That's what happens. Then what happens is in the help of coordinate machine, you see this is what happens. So this is a component, and then what happens, it has been touched with the various layers to check whether all the points has been marked or not, and the coordinate. So this is what happens. Then what happens is, see the in the case of cmm, the actual shape of the object is converted into coordinate points using the probe. So what happens here, with the help of the probe, the object has been turned into coordinate points. That's what we are saying over here. So the actual shape, automatically the actual shape of the object is always getting converted, it's always getting converted into the coordinate points using the probe. Based on the coordinate data, a substituted shape is generated by the cmm machine. A substituted shape is generated by the cmm machine, where the computer checks the physical characteristics data of the substituted shape with the given data, and then finally a report will be prepared. So what happens in the case of cmm? Okay, the main thing is what? Okay, cmm is like this actual shape of the object. The actual shape of the object is always converted into coordinate points. The actual shape of the object is always converted into the coordinate points using the probe. Then based on the coordinate data, it is always based on the coordinate data, a substitute shape is generated by the cmm machine. A substitute shape is generated by the cmm machine. Okay, the computer then checks the physical characteristics data of the substituted shape. The computer then checks the physical characteristics data of the substitute shape with the given data, and a report will be prepared. This is what happens over here. So, okay, this is what happens over here. Okay, so in the case of an CMS, what happens is like the term coordinate. Okay, keyboard machine. The term coordinate measuring machine refers to an instrument machine that is capable of measuring all three orthogonal axes. So such a machine is abbreviated CMM. So what happens is a CMM enables the location of point coordinates in 3D. Okay, it is mainly with the help of the 3D space, that's three-dimensional work. It simultaneously captures both dimensions and orthogonal relationships. It also captures both, what all? Both, that is dimensions and orthogonal relationships. Another remarkable feature of a CMM in its integration with the computers, the computer provides additional power to generate. The computer provides, see here what happens is the computer, okay, the computer provides what? The computer provides additional power to generate 3D object as well as to carry out complex mathematical calculations. So complex objects can be dimensionally evaluated with precision. See, this is a very complex object. So with the help of this probe and cmm, we are evaluating the dimensions by touching, okay, and we are designing it in the computer, and then we are doing the analysis. So that's what happens over here. So this is a video which is showing that, okay, this is a video which is showing that cmm. So what happens over here is like, what happens, the first batch, okay, the first batch of cmm, okay, happens. So what happens over here is what, it is simultaneously, okay, so in such a machine is properly divided, a cmm enables the location of point coordinates. You see, check the probe is doing, look on the figure, look on the slide where you can see the probe, what the probe is doing. Okay, so what happens is a cmm enables the location of point coordinates in a three-dimensional space. Then it simultaneously captures, okay, it simultaneously captures both dimensions and orthogonal relationships. It simultaneously captures both dimensions and orthogonal relationships. Another remarkable feature of a cmm, another remarkable feature of a cmm in its integration with a computer, where the computer provides additional power to generate 3D objects as well as to carry out complex mathematical calculations. Okay, that's what happens. So what happens is like, okay, in the case of cms, it simultaneously captures both dimensions and orthogonal relationship. Another remarkable feature of a cmm in its, okay, in its both dimensions is integration with the computer. The computer provides additional power to generate 3D objects as well as to carry out complex mathematical calculations. Okay, and what happens, the complex objects can be dimensionally evaluated with the precision and the speed. This is what happens. So in the main thing, what happens, these are the major components of a cmm. Okay, so these are the major components of a cmm. We have got various components. Okay, this is what the major uh, components of a CM. So in the case of major components means, first one is a machine structure. Okay, first one is what? We have a machine structure. Okay, we have a machine structure. Second one is the linear measurement transducers. Okay, where we have a linear measurement transducer. Then we have a probing system. Then automatically we will be having computer aided hard softwares. Okay, then we will be having computer aided softwares. Then what have probe system, then linear measurement transducers. So all this are required for the main parts of a CMM. So we can say the machine structure or main structure. Okay, what happens in the case of a machine structure? All the components, okay, all the components will be housing. Okay, all the components will be housing in the main machine structure, or we can say the machine structure. We can also name it as main structure, which will be acting as the main component, where all the parts of the component will be housing on it. So what happens here? What we will be having? We will be having a probe structure, bridge, main structure or base. Then we will be having the axis. Okay, we'll be having the axis, length measuring system, the machines base with work table. All that are the basic structures. See, this is the basic component. So all these are the basic structures where we can see the machine base. Okay, with the work table. So this is the machine base, the work table. Then what we have a length measuring system. Pro will be there for length measuring system. Then the axis. What are the axes are? X, Y, Z. Which are the axes are comparing 3D for in the case of 3D. In the case of 3D machining. Okay, as we know, it's a three-dimensional working model. So in the case of design, in the case of CMM design, okay, mainly in the case of CMM design, it is incorporated the basic components of three coordinate axes. It is mainly incorporated with the basic components of three coordinate axes. So what happens over here is what happens each axis is fitted with a linear measurement transducer. That's what we say. Each axis is always fitted with a linear measurement transducer. So can any one of you tell me what will be the movement of the axis which describes in the case of CMM? Mohammed Fardeen, can you tell me what will be the movement of the axis which mainly describes in the case of CMM? What will be the movement of axis which mainly describes in the case of CMM? Should I call the name? Fardeen?
Sir,
Yeah. Can you tell me what will be the movement of the axis which fully describes the CMM? As we are told, it is a 3D, no three-dimensional space. What will be the axis?
vertical axis.
Ah, vertical axis, yes. Then only vertical axis is enough. In the case of 3D,
Horizontal,
vertical, horizontal, then
inclined.
inclined. Okay. Oh, okay. We can say X, Y, Z, vertical, horizontal, and inclined, all that. Okay, that's right. Thank you. So then what happens is like here the movement of axis X, Y, Z axis fully describes the measuring envelope. Then what happens? Each axis is fitted with a linear measurement transducer. Okay. So what happens in each the axis, whether it's linear, whether it's inclined, whether it's vertical, whatever be the axis, it is always fitted with a linear measurement transducer. Okay. It is always fitted with a linear measurement transducer. Okay, for positional feedback and display digitally. For positional feedback and digital display. Okay, and display digitally. Then the movement along the three planes is through precision guideways. Okay, the movement along three planes is through precision guideways. Then the most widely used guideways are air-bearing granite guideways. Okay. So what happens over here is what happens all CMM designs. Okay. All CM designs incorporate the basic component of three coordinate axis, where the movement of the XYZ axis fully describes the measuring envelope. And then what happens is each axis is fitted with a linear measurement transducer for positioning the feedback and display digitally. The movement along the three planes is through precision guideways. It is always through the precision guideways. Then what happens is the most widely used guideways are air-bearing granite guideways. Okay, so just note it down. The most widely used guideways. Okay, the most widely used guideways are always the air-bearing granite guideways. Air-bearing granite guideways are most usually used. They are always free. They are always free of the sticking effect, and in the long term it can damp down vibrations effectively due to the weight and the air bearing all spectrum. So nowadays what happens is that the main structure, the CMM frames are built from aluminum alloys. Okay, what makes the main purpose, where what makes the frame of the CMM to be aluminum alloy? What are the major factors of an aluminum to be considered? Muhammad Fardeen, you couldn't tell me why do we use the frames of the CMM with the help of aluminum foil alloy? Sorry, Muhammad Fardeen.
Sir,
No, sorry. Fateh, Muhammad Fateh.
ഞാനാ
Yes, Fateh. why do we use
The
nowadays
light
CMM
is
frames
stronger
are
and
built for
high strength in the long.
yes, light strong and high strength. That's it. Thank you. So nowadays CMM frames are built from aluminum alloys or new materials like ceramic and silicon carbide, which increase stiffness of the measuring axis is required like for the scanning application. So what happens is nowadays in the case of CMM frames, which are built from aluminum alloys, okay, which are mainly built from aluminum alloys or new materials, okay, or aluminum alloys or new materials, okay, aluminum alloys or new materials that has nowadays the CMM frames are built from aluminum oil alloys or new materials like ceramic and silicon carbide, where increased stiffness of the measuring axis, is required, like for scanning application. So the length measurement, okay, the length measuring system consists of measurement scales and scale readers. What happens? The length measuring instrument, okay. So the length measuring system consists of measurement scales and scale readers. Then the position of the stylus system is reported by the length measuring system to the controller. What happens in the cases? The length measuring system, okay, the length measuring system consists of a measurement scales, okay, the length measuring system consists of a measurement scales and scale readers. The position of the stylus system is reported by the length measuring system to be the controller. Then commonly used are stainless steels. Okay, commonly used stainless steels, glass, etc. So all these are the components which are used. So you know what is the purpose of a linear measurement transducer. So in order for having the correct measurements for measuring system. Then what happens? Then we have a probe system. You see that? Then we have a probe system, or we can say probing system, whatever maybe. Okay. So it is a sensory part of the coordinate measuring system, CMM, responsible for gathering the data, the tip. Okay, responsible for gathering the data. As you have seen over here, this is the probe. Okay, sorry. As you see here, this is the probe. Okay, this is the probe. So what happens is it is sensory part of the coordinate system, sensory part of the coordinate measuring system, responsible for gathering data from the workpiece. Then probes are inserted into the probe arm. Automatically what happens? The probes are always inserted to the probe arm, which is supported by the moving frame. Okay, which is always supported by the moving frame. That's what happens. What happens in the probing system is probe is a sensory part of a coordinate measuring machine. Okay, what happens is probe is a sensory part of a coordinate measuring machine responsible for gathering data from the workpiece. That's what happens. So here what happens, it is a sensory part of the coordinate measuring machine. It is always the sensory part of a coordinate measuring machine responsible for gathering data from the workpiece. It's mainly responsible for gathering data from the workpiece. Then probes are inserted in the probe arm. Okay, probes are inserted in the probe arm, which is supported by the moving frame that allows the movement of the probe relative to the workpiece. That allows the movement of the probe relative to the workpiece. Okay, that's what happens. So in the case of a probe system, what happens in the case of a probe system? Okay, probe is a sensory part of a coordinate measuring machine responsible for gathering data from the workpiece. Then probes are inserted in the probe arm, then it's supported by a moving frame that allows the movement of the probe relative to the workpiece. There are different probes of contact and non-contact type. In contacting probing system, the acquisition of the measuring points take place by probing the surface using a stylus and simultaneously reading the length measuring system position. The probe contains one or more styli or are interchangeable. The stylus is a hard ball, steel or ruby soldered into the end of a small shaft. Different tipped stylus were also available for different applications. Optical and laser probes are for the contact or for the non-contact type of machines. So this is what happens in the case of probe system. So it is the main system which helps to gathering the data of the instrument. It's the main system which helps in the gathering the data of the instrument. So what happens in the probing system is it is the sensory part. Okay, it is a sensory part of the coordinate measuring machine. It is always the sensory part of the It's always the sensory part of the coordinate measuring machine responsible for gathering data from the workpiece. So what happens in the probing system is it is always okay. It's always the sensory part of the coordinate measuring machine. It's always the sensory part of the coordinate measuring machine responsible for gathering data from the workpiece. It's mainly responsible for gathering data from the workpiece. Then probes mainly are inserted in the probe arm, which is supported by the moving frame that allows the movements. Okay, that always allows what allows the movements of probe related to the workpiece. There are different probes of contact and non-contact type. So this is what mainly rubbing action. Then comes the machine controller and the computer. Okay, then comes the machine controller and the computer. That we can say it is mainly the computer hardware and software. So we can divide into two. In the case of computer hardware, means it's the machine controller and computer, and then we have a software system. So as a unit we can say it's a together system. That's what this is what so computer hardware and software, this is what we say. So control everything. So what happens, first we have a machine controller system. Okay, first what we having, we will be having a machine controller system. First in this case what we will be having, we will be always having a machine controller system. So what happens is a controller of cmm, okay, mainly what a control, okay, a controller of a cmm fulfills many functions like access control, object probing, programming, control of measuring run, data acquisition and evaluation. Then coordinate measuring machines are controlled either manually or by a computer. In terms of control technological equipment, two types are in used. Okay, in consist of in terms of control technological equipment, two types are in use. Manually operated CM with computer, manually operated CM with computer assisted data evaluation and reporting. Then CNC, CMM with offline programming capability and measuring data feedback. That's what as high degree, okay, as high degree of automation, has high degree of automation and high flexibility at the side. CNC and CMMs are widely used. Hence what happens? Hence the control of the CMM and the process for obtaining data are performed by the computers. So the computer analyzes the measuring results obtained to arrive at a comprehensive conclusion regarding the dimensional form and position tolerances of the probe from the elements. So what happens over here is we have a computer hardware and software system. So first we are dealing with the computer hardware, that is the machine controller and the basic computer. Which happens, it mainly fulfills functions like what? Access control. Please note it down. The functions like what? Access control, object probing, programming, control of measuring run, data acquisition, and evaluation. So within the help of computer hardware and software, we have a machine controller and a computer, which is probably related to the hardware system. Where what we have the hardware system, what happens? A controller, okay, a controller of a CMM. What happens? Mainly the controller of a CMM fulfills. It mainly fulfills many functions. It always fulfills many functions like what? Access control. Okay, it controls many functions like first one access control, object probing, programming, control of measuring run there. So first one is access control. So it controls the axis to its rotations and we know in order for detecting the coordinate points. Then what happens? Object probing. Object probing means you probe the object. You will check the object for everywhere. Then programming control of measuring run. It will control the program. It will not move out from the object or take the unrequired dimensions, everything. So what happens? Programming control of measuring run. Then data acquisition. Then finally what happens? The data acquisition. It will capture the data. Okay, it will capture the data. That's what it's a data acquisition. It will capture the data. Okay, data acquisition and evaluation. That's what happens. Then coordinate. What happens is then coordinate measuring machines. Okay, coordinate measuring machines are controlled either manually or by a computer. In the case of CMM, it is mainly controlled either manually or by a computer. So in terms of control technology equipment, there are two types: manually operated CMM and CNC. CMM with offline programming is also possible. Then comes the software. Okay, then comes the okay, then comes the software. Okay, then comes the software. What happens to the software? Okay, then comes the software. What happens to the software? The software is it analyzes. Okay, mainly it analyzes. It analyzes the data and obtain the information regarding size and shapes. What happens is here we have a software, but it analyzes. Okay, software when the it analyzes the data and obtain information regarding the size, shape, form, and form, location, and orientation. Then what happens? Input devices are generally keyboards and control box, and output devices vary from the CRT monitor, hard drives, tapes, etc. The computer must have aligned the parts, control the machine motion, make corrections, make calculation, and evaluate the data. So these are the main. Okay, these are the main components. So these are the main components of a CMM, where what happens? It is a physical base of made of cast graphite with three particles. It is rigid in construction then it is sensitivity to vibration, it has good damping characteristics. Then what happens? It has long time vibration, it has good damping characteristics, long time stable, then made of cast iron, granite, aluminum, ceramic, carbon fiber. It uses DC motor to drive, etc., etc. All that are available. Then linear measurement transducers. This provides in all three axes, provides feedback for the position axis of CMM machine. It controls the scale sector. I think the most common scales are 412 readers. Then the probe system. This we have already discussed, and the computer system. Now we will go with the construction. Okay, now we will be drawing. We will be going with the construction and working of CMM. That's what the construction and working of CMM also we shall discuss. So what happens over here is the part. Okay, the machine has a movement in X, Y, Z direction. That's why it is called three-dimensional. Okay. So the displacement along each axis is measured by linear measurement system, and the readings are sent to ECU. Okay. Then what happens? Computer build and process the information. Mean what happens? The computers build and process this information. Okay. Then the computer builds and process this information. Then imaging probe is attached to the end of the Z axis. So what happens? Imaging probe is always attached to the end of the Z axis. So in the case of construction and working of CM, the machine has movements in XYZ directions. Okay, in the case of construction CM, the machine has movements in XYZ directions. Okay, construction and working of CM, the machine has movements in XYZ directions. Okay, machines has movements in XYZ directions where the displacement along each axis. Okay, where the displacement along each axis is measured by the linear measurement system. Is measured by the linear measurement system. That's what happens. So what happens is in the case of construction working of CMMS, the machine has movements in XYZ direction, and the displacement along each axis is measured by linear measurement system, and the readings are sent to the ECU. Then computer build and process this information. The image probing is attached to the end of the Z axis. Then when the probe touches the surface of a bar, places sensors triggered. Then after calculating a sufficient number of surface points, the data is then analyzed by software. Then various algorithms, software will analyze the data set and construct a 3D image of the part. So this is what happens in the case of a CMM. Okay, what happens is like the machines. Okay, the machines will be always having the main three parts. Okay, so the machines has movements in the XYZ directions. The displacement, okay, there's a displacement. So what happens over here is the part is placed. What happens here is the part is placed in the work table CMM at a suitable location. Okay, in the case what happens is it is mainly placed in the part. So what happens over here is here what happens, construction working means what the part is, and now we can say an operation axis. What will be the operation? What happens? So what we first we will have a part. The part will be always placed in the work table. Where is the work table? See, this is the work table. Okay, this is the part will be always placed in the work table. See, part will be always placed in the work table. So this is the work table of the CMM at a suitable location, usually central to the machine axis, mainly to the center. See, the center to the machine axis, and to access all the part surfaces. In order to aspect all the part surfaces, which has to be inspected with the help of the probe. Okay, it may be necessary to clamp the part to the work table depending upon the size of the part and the types of probes used. So what happens is what we have, the part is placed on the work table of the CMM at a suitable location, usually central to the machine axis, to access all part surfaces to be inspected with the probe. Then it may be necessary to clamp the part to the work table depending upon the size of the part. So what happens? It may be necessary to clamp the part to the work table depending upon the size of the part and the types of the probes used. If many similar parts are to be inspected, a reference location point is established. A reference location point is established. Okay, a reference location points of operation is the part is placed on the work table of the CMO. Okay, what happens is here what we have, the part is placed. Okay, mainly the part is placed on the work table of the CMO at suitable location. The part is placed on the work table of a CMM at a suitable location, usually central to the machine axis. To access all the part surfaces to be inspected with the probe. Where all the part surfaces are inspected with the probe. Okay, where all the part surfaces are inspected with the probe. So it may be necessary to clamp the part to the work table depending upon the size of the part and the types of the probes used. If many similar parts are to be inspected, a reference location point is established. A reference location point is established with a reference post precision cube, with a reference precision cube or sphere. That's what happens. So what happens is, in the case of operation, the part is placed on the work table of the CMM at a suitable location, usually central to the machine axis, to access all the part surfaces to be inspected with the probe. It may be necessary to clamp the part to the work table depending upon the size of the part and the types of the probes used. If many similar parts are to be inspected, a reference location point is established with the reference precision cube sphere. So the probe is moved to make contact with the surface of the part. What happens is the probe is moved to make contact with the surface of the part, and instantaneously the coordinate positions to the probe are accurate. So in the case of a CMS control, what happens? It is returns to neutral position. The dimension and geometric angle are calculated, compared, and evaluated. So that's what happens in the case of CMM, where the points are compared, calculated, and evaluated with the help of a CMM controller, where the compensation is made for the radius of the probe tip, and any limited overdraft of the probe fuel may be neglected. So these are the major factors of the CMO. So with the help of a computer and software, that's what happens. Okay, with the help of computer and software, this is what happens. So this is the machine working. Okay, so this is the mainly the machine working. Okay, so this is the mainly the machine working where the probe will be taking place. I hope so you are seeing. Okay, see, this is the probe. Okay, and this is the machine. So all small, even very high and very small dimensions will be noted down, and it will be taken consideration in order for the proper dimension. So if a small dimension is changed, automatically it may change the all the coordinate points, and it may be not suitable. So it's a very precise measuring, and comparatively it is less time consuming, and to a point it is a, but without making a prototype, we can do all the machine, all the aspects, and check whether it is done or not. That's what happens. Okay, okay, then like that. The next class we will be afternoon session. We will be having the same session. So we will we'll continue with this regarding the types of CMM. Okay, whether regarding the various types of TCMM. For timing, I'll stop. Okay.